Hi and welcome back. In this lecture I want to give you a brief introduction about GPUs. I want to tell you what GPUs are and what GPUs are good for. There are 4 key points I want to stress during this lecture. First, GPUs are specialized hardware, initially designed for doing just graphics. Second, there are integrated GPUs and dedicated GPUs. Third, when using dedicated GPUs, we still need a CPU to provide GPU with basic OS services. Fourth, one of the major weaknesses of GPU, at least of GPU we're going to use in this course, is that the data transfer between CPU memory and GPU memory and vice versa is relatively slow. But let's start with the lecture. What are GPUs? A GPU stands for Graphical Processing Unit. A GPU is a specialized microcircuit to accelerate the creation and manipulation of images in video frames for display devices. A specialized microcircuit is a special hardware specifically designed for solving certain kind of tasks and problems at a maximum speed. However, they might not be particularly good or efficient in solving other kind of tasks. GPU is specialized in solving graphics problems, while for instance might not be good in application characterized by little parallelism or irregular data access. So, in summary, when it comes to graphics tasks, GPUs are computational monsters. They generate real monsters in your display's device. What are GPU good for? Well, GPUs are designed for processing images at the maximum speed. Image processing is a typical example of data parallel problem, where operation on data, in this case pixels of images, are performed in parallel. As example, if you want to manipulate a frame of a video, you might need to process roughly 2 million pixels. If you want to render in real time, we need something between 30 and 60 frames per second. And we have approximately 33 milliseconds per frame. A GPU can do this, process 2 million pixels in less than 33 milliseconds. Many image processing problems are characterized by pixel calculation that are independent on other pixel calculation. For this reason, this calculation can be easily done in parallel without requiring synchronization and/or sophisticated control. In summary, GPUs are good for applications that are data parallel in nature and do not require synchronization and/or sophisticated control. In the last decade, GPU became one of the main workforces in HPC supercomputer centers that are aiming at lowering down the consumption of power and energy by supercomputers. But why is that? Well, the reason is that GPU provides a lot of parallelism at low clock speed. Keep in mind that the power consumption in a processor is a qubit function of the clock speed. So, by decreasing the available parallelism and at the same time by decreasing the clock speed, GPU provides an excellent ratio of floating point operation per second per watt and is very power efficient architecture. It's not a surprise that the Green 500 list, that is a list ranking the supercomputers according to the power efficiency, feature also supercomputers with GPUs in the first 6 places. We can broadly divide GPUs into 2 categories, integrated GPUs and dedicated GPUs. As the name says, integrated GPUs are built into the main processor. These are the most common GPUs in laptops, like the one I'm using now. You probably heard about Intel HD or Intel Iris graphics. You might want to check your laptop characteristics and figure out if you have one of these integrated GPUs. I can also check mine. Let's see. So I get out from my PowerPoint. I check about this Mac. And as you can see here, I have Intel Iris graphics. The second category of GPU is the dedicated GPU category. This is the category we are more interested in. Dedicated GPUs are standalone GPUs with their own processor and memory. They require more power. Yes, we need to pay energy to move data between GPU and CPU. But these are the GPU that provide the highest performance. In this course, we are going to use dedicated GPUs. What is the main difference between integrated and dedicated GPUs? Dedicated GPUs have their own memory, while integrated GPUs share memory with the CPU. There are several dedicated GPU vendors Among this one, probably the most successful when it comes to GPU for HPC and deep learning application is NVIDIA. One of the problems of dedicated GPUs is that they don't run an operating system. How do we solve this problem? The solution is to have a hybrid system consisting of CPU and a GPU connected via PCI Express bus. In this hybrid configuration, the CPU acts as a host and it provides GPU with basic management and services, since the GPU doesn't run an OS. In this configuration, the GPU acts as an accelerator or coprocessor, and it provides the computational power and increased parallelism. In this course, we are going to use dedicated GPUs connected to CPU via PCI Express bus. The data movement between GPU and CPU and vice versa is relatively slow. When I say relatively slow, I mean when compared to the speed in moving data from GPU to its own memory, called GDR-RAM, and from CPU to DRAM. The figure in this slide shows the data transfer bandwidth between different parts of the system, comprising an NVIDIA Tesla K40, connected to CPU via a third-generation PCI Express. From this figure, you can see that bandwidth between GPU and CPU memory is roughly 10 times smaller than the bandwidth to GDR. The good news is that this problem is now solved with the arrival on the market of the new NVIDIA GPUs. These GPUs provide much faster link between GPU and CPU, called NVLink. So, in summary, in this lecture, I focus on 4 main points. First, I have emphasized that GPUs are specialized hardware initially designed for graphics application and now widely used in many different areas. Second, GPUs can be either integrated in the processor or have a dedicated chip. In this course, we focus on dedicated GPUs. Third, when using dedicated GPUs, we need a CPU that acts as a host and provides OS services to the GPU. Fourth, to move data from GPU memory to CPU memory is relatively slow. In the next lecture, we are going to look at basic concepts and philosophy driving the design of a GPU architecture. So, talk to you in a bit.